In this video, we're going to look at forming a new equation with related roots, and we're going to extend it to cubics. So for cubics, we know that we've got three roots, alpha, beta, gamma, and we can think about the sum of the roots as being minus b over a, the pairs c over a, and the product minus d over a. To form the new cubic, it's similar to forming the new quadratic, but the pattern looks like this. It's minus the new sum plus the new pairs minus the new product. So let's try example 1. We're given a cubic, 3x cubed minus 10x squared plus 5x plus 1, and we're told the roots are alpha, beta and gamma, and it says find a new equation with integer coefficients with related roots. So the roots are going to be 1 over alpha, 1 over beta, 1 over gamma. First thing you should do on a question like this, if it doesn't structure it for you, just think about what the sum of the roots is. So what is alpha plus beta plus gamma for this question? Okay, so the sum of the roots would be minus b over a so we've got 10 over 3. The pairs, which would be alpha beta plus alpha gamma plus beta gamma, which we can write as the sum of the pairs, would be c over a, so we've got 5 over 3, and the product alpha, beta, gamma would be minus d over a, so it would be minus 1 over 3. So once we've done that, now we're thinking about like what's our new sum, what's our new pairs, what's our new product. So the new sum would be 1 over alpha plus 1 over beta plus 1 over gamma. Now obviously we're aiming to write everything in terms of alpha plus beta plus gamma, alpha beta, alpha gamma, beta gamma, or alpha beta gamma. So we can't, before we evaluate this, we need to group it together. The common denominator for this would be alpha, beta gamma. So we can see that this first one we'd multiply by beta gamma on the top and beta gamma on the bottom. This one would be alpha gamma, and this one would need alpha beta on the top and alpha beta on the bottom. Once we've done this, we should notice on the top of the fraction, so when we add these fractions together, common denominator, so we add the tops, we've got the sum of the pairs, haven't we? So now we can evaluate our new sum. We've got the sum of the pairs, which is 5 over 3, divided by the product of our roots, which is minus 1 over 3. So we get minus 5 for our new sum. For our new product, oh sorry, let's do the pairs. Not that it really matters, we have to do them all, but I suppose I'll do it in order. The new pairs. This is the one where you've got to be a little bit careful because you're thinking about the pairs of the roots. We have to multiply them in different combinations. We've got 1 over alpha times by 1 over beta plus 1 over alpha times by 1 over gamma and plus 1 over beta times by 1 over gamma. So think about it, first of all, well, the way that we multiply fractions, multiply the tops, multiply the bottoms. So we've got 1 over alpha beta plus 1 over alpha gamma plus 1 over beta gamma. Now you've got to be careful here. If you're not good with your fractions, you're going to get into a mess. Like, we need to get a common denominator, like we did here. We need the common denominator. So you might just think, oh, let's just times everything together, but don't do that. There's actually a much neater way. Like you're not just multiplying everything together to get this denominator. You essentially what you're doing is looking at what does each denominator have, and what could I write it over that would be like, when we think about this, like the lowest common multiple, but obviously we're not thinking about numbers, but like we want the lowest common denominator that we can get, essentially. And if you look at it, if you think about it carefully, like there's only alphas, betas and gammas. So for this first one, you can just multiply the top by gamma and the bottom by gamma. For this one, we can multiply the top by beta and the bottom by beta. and this one we can multiply the top by alpha and the bottom by alpha, and then your common denominator that you need is just alpha, beta, gamma. So once we've got this common denominator, we can add the tops, and we get the sum of our roots divided by the product of our roots, and the sum of our roots is 10 over 3. The product of our roots is minus 1 over 3. So we'd get minus 10. Last thing is our new product, which I think is actually a bit easier. So if you multiply our roots together, we've got 1 over alpha times 1 over beta times 1 over gamma, which is just 1 over alpha, beta, gamma, which is 1 divided by minus a third, which is minus 3. So we actually don't need to worry about the fact that they're integer coefficients, because we're going to get we haven't got any fractions, so we're going to get integers straight away. All we've got to do now is just write our cubic. Okay, so the answer would be x cubed minus our new sum, which is minus 5 x squared, plus our pairs, which is minus 10 x, and then minus our product, which is minus 3. Don't forget to write equals 0. I should have mentioned that when you're forming a new equation, you should write equals 0. Okay, so it'll be x cubed plus 5x squared minus 10x plus 3 equals 0. Example 2, we've got 3x cubed minus 5x squared plus x minus 3. And again, we want to form a new equation with integer coefficients, and the roots for this one are going to be alpha, beta, beta, gamma, and alpha, gamma. So let's start by thinking about the sum of our roots, which would be minus b over a. So that would become 5 over 3. Our pairs, which would be c over a, so that would be 1 over 3. And our product would be minus d over a, so that would be minus 3 over 3. So we got. Okay, so new sum. The roots are alpha, beta, beta, gamma, and alpha, gamma. So if you think about it, right, when we add these together, that new sum of these new roots is the same as the pairs for our original one. So that we just get 1/3. Okay, new product. Sorry, I keep doing this. New pairs. So we've got to multiply alpha, beta by alpha, gamma. We've got to multiply alpha, beta by beta, gamma. And we've got to multiply beta, gamma by alpha, gamma. Okay, so there's 3 combinations for our pairs. Now when you do this, when we start to get into these slightly more complicated questions, there's like another way of us thinking about it, which will help a lot actually. I'm going to show it to you now. Instead of multiplying all these combinations together, right, normally we'd write the sum of the pairs as the sum of alpha, beta. Like that just signifies in general the sum of the combinations of the pairs, doesn't it? Now for this question, you could write that as the sum of one of our roots, which is alpha, beta, multiplied by another root. Let's use beta, gamma. You can use any combination in here. The same principle will apply. It doesn't matter which one we're calling which. Now if you think about this like a shorthand way of doing it, we could write that as the sum of alpha, beta squared, gamma. Now if you'd multiplied other ones, it might not have been alpha, beta squared, gamma, it might have been alpha squared, beta, gamma, but the same principle of symmetry applies. What we could now do here is we can take out a common factor of alpha, beta, gamma, and we'd be left with just the beta. Where people start to get a little bit freaked out is if you don't realise that the sum of the roots, beta, it doesn't matter what letter we use in there, like that would be the same as alpha, beta, gamma times the sum of alpha if I wanted to. Like if I'd have used a different combination, it would have straight away looked like this, but like the sum of a root is the same as the sum of a root. Like the roots of the alpha, beta and gamma can be written either way. Okay. That technique there takes a little bit of getting used to, but let me just go back to what we've written here and we'll hopefully see that we should get the same answer. This is useful if you can get used to it though on some of the more complicated questions. So look what, when we expand this out, look what we've got. So that would be alpha squared beta gamma plus alpha beta squared gamma plus alpha beta gamma squared. And then now when you've written it all out in long form, it's like the sum of these possible combinations, isn't it? Like we've got alpha beta squared gamma, but we've also got alpha squared beta gamma, and we've got alpha beta gamma squared. So by writing it like this in the short way and saying, well, everyone would have alpha beta and gamma and you can take it out, is a bit quicker, but maybe a little bit more scary the first time you see it, than if you do the long way and you get alpha beta gamma. Notice that each of these have a factor of alpha beta gamma, and then if you take that out, you'd be left with alpha plus beta plus gamma, which is what we were doing here. Like we noticed that, well, they'd all have a factor we could take out, and we're left with the sum of the roots, which is the same here. Don't worry about this bit for now. To be honest, this is a technique which is probably going to come up a lot more useful in second year. So if you want it for the first year questions, you will be able to just expand them all out. But I just thought it was a nice opportunity to show you this way of thinking about it. Either way, we've just got to evaluate this now, haven't we? So the product of our roots is 1. The sum of our roots is 5 over 3. So we get 5 over 3. So we've got our new sum, we've got our new pairs, and we just need to finish off with our new product. So our new product, if we multiply them all together, we've got alpha beta times beta gamma times alpha gamma. We would get alpha squared, beta squared, gamma squared, which hopefully we can see that we could write that as alpha beta gamma squared. And we know alpha beta gamma is 1, and 1 squared is 1. So we're nearly done. We've just got to form our new cubic. It'll be x cubed minus our new sum, which is 1/3 of x squared, plus our new pairs, which is 5 over 3, minus our new product, which is 1, set it equal to 0. All that hard work, don't lose 1 mark, integer coefficients, multiply everything by 3, and we get 3x cubed minus x squared plus 5x minus 3 equals 0. Alright guys, so this technique, it's starting to get a bit heavy on the algebra, isn't it? But there's lots of exam questions for us to practice on this, and possibly rewatch the video and pause it and try again if you're not sure, because it's something that we need to, I think, look at a few times, this one. Alright, thanks guys.